naming an ionic compound with a transition metal. So the question here says, write the name for each of the following ionic compounds. Let's start with CdBr2, the white powder at the bottom right here. First, let's make sure that it's an ionic compound. And remember, ionic compounds are made from a metal and a nonmetal. Metals are to the left of this zigzag line, this staircase, sort of on the right side of the periodic table. Everything to the left is a metal, and everything to the right of that is a nonmetal. So because Cd is to the left of that, it's a metal. Because Br is to the right of that, it's a nonmetal, and so we're dealing with an ionic compound. Now to name ionic compounds, take the first element and name it exactly as it is named on the periodic table. So here Cd is cadmium. For the second element, take just the first syllable from the name on the periodic table. So here it's bromine, the first syllable is brome. And add the ending ide, IDE, to show that it's in a compound. Now, normally, this would be the full name. But because cadmium is in that valley area in the periodic table, it's a transition metal. Transition metals are all of the elements in that valley area. And the unique thing about transition metals is that they can have different charges in different compounds. So when you name a specific compound that has a transition metal, you have to say what the charge is on that transition metal in that specific compound. So we have to say what the charge is on cadmium in CdBr2. We're going to do that by putting that charge as a Roman numeral in parentheses after the cadmium. But first, we have to figure out what that charge is. So, in order to find the charge on cadmium, we're going to make a little algebraic equation. Now, the charge of the overall molecule is given in the top right. If nothing is written there, then the overall charge, the charge of the whole thing, is 0. So whatever the charge is on the cadmium and the bromines, they all have to add up to 0. Now I have two elements. I have cadmium and I have bromine, and I'm going to separate them by a plus sign. I have one cadmium. If the subscript is never written in, it just means you have one. And I don't know the charge on cadmium. So the way you say I don't know in math is X. I have two bromines. And the charge on bromine, because it's in group 7A, is -1. So I'm going to put a -1 in for the charge on bromine. So now I have X minus 2 equals 0. Add 2 to both sides. It cancels on the left, and you get X equals +2. That +2 is the charge on cadmium in this compound. And so we're going to list that in the name as a Roman numeral in parentheses after the cadmium. So the full name for CdBr2 is cadmium 2 bromide. So if you take cadmium and you mix it with bromine, you will get cadmium 2 bromide, cadmium 2 bromide. And that's used in the manufacture of photographic film. How about NiO? What's the name for that? First, let's make sure it's an ionic compound. So we have nickel, or Ni, that's to the left of that staircase, so it's a metal. O is to the right of the staircase, so it's a nonmetal. If you combine a metal and a nonmetal, you have an ionic compound. To name ionic compounds, take the name of the first element exactly as it is on the periodic table. So Ni is nickel. For the second element, take just the first syllable. So the first syllable for oxygen is ox, and then add the ending ide, IDE, to show that it's in a compound, that the nickel and oxygen are sticking together. Now, because nickel is a transition metal, we have to say what the charge on the nickel is in this specific compound. And to do that, we're going to make a little algebraic equation. Look at the top right. If nothing is written there, everything has to add up to 0. Now I have two elements. I have nickel and I have oxygen. Separate those by a plus sign. I only have one nickel, because no subscript is written in, and I don't know the charge on nickel, so I'm going to write X. That's what I'm trying to figure out, the charge on nickel. I only have one oxygen, because no subscript was written in, and the charge on oxygen, because it's in column 6A, is -2. So I'm going to write in -2 there. So now I have X minus 2 equals 0. Add 2 to both sides, it cancels on the left, and X equals positive 2. So that positive 2 is the charge that's on nickel in this compound. And so we're going to list it in the name as a Roman numeral in parentheses after the nickel. So the name for NiO is nickel 2 oxide. So if you take nickel, you mix it with oxygen, react it with oxygen, you'll get nickel 2 oxide. And that's used in ceramics. Well, first it occurs naturally as a mineral called bunsenite, but it's also used in ceramics and in glassware for coloring. How about Ag2S? What's the name for that? First, let's make sure we have an ionic compound. Ag is to the left of the staircase, so it's a metal. S is to the right of the staircase, so it's a nonmetal. If you mix a metal and a nonmetal, you have an ionic compound. To name ionic compounds, take just the name of the first element exactly as it is on the periodic table. So Eg is silver. Then for the second element, take just the first syllable. So S is sulfur, the first syllable is sulf. And add the ending ide, IDE, to show that these two elements are in a compound. Now, because silver is a transition metal, in that valley area on the periodic table, we have to say what the charge is on silver as a Roman numeral in parentheses after the silver. So to find the charge on silver, we're going to make a little algebraic equation. So all of the charges in the compound have to add up to whatever is in the top right. If nothing is written there, then everything has to add up to 0. I have two elements in this compound. I have silver and I have sulfur. I'm going to separate those with a plus sign. I have two silvers, and I don't know the charge on silver, so I'm going to list it as X. That's what we're trying to figure out. I only have one sulfur because it doesn't have a subscript written in, and the charge on sulfur, because it's in column 6A, group 6A, it has a -2 charge. So I'm going to write in -2 there. So now I have 2x minus 2 equals 0. So first add 2 to both sides. It cancels on the left. You have 2x equals positive 2. Then divide both sides by 2. It'll cancel on the left, and you'll be left with x equals positive 1. So that positive 1 is the charge on silver in this compound. And so we're going to list that as a Roman numeral in parentheses after the name silver in the name. So Ag2S is silver 1 sulfide. And this is a good point to just point out that this 1 here is not representing the subscript. It's representing the charge on silver. And to figure it out, you have to make these little algebraic equations. So Ag2S is silver 1 sulfide. So if you take silver and you mix it with sulfur, you'll get silver 1 sulfide. And that's used to detect light in cameras, in photography. So it's used to capture the different types and amounts of light in an image onto a surface. For sulfur here, I have that what looks like almost a ball. That ball is a moon for the planet Jupiter in our solar system. Earth only has one moon, but Jupiter has 79 moons, and one of them is this moon. It's called Io, and it's completely covered in sulfur. You can see that yellow there is sulfur. All the sulfur is coming from volcanoes on that moon. There are over 400 active volcanoes on Io, and some are taller than Mount Everest. They spew up sulfur and magma over 300 kilometers high, and here that's what this blue plume is coming off of the surface. Here's an image where you see a lot of red patches. Now most of the surface is made of just sulfur and sulfur dioxide frost, but at places where it gets hot, the sulfur melts. And when sulfur melts, this is what happens. So you can see it turning a dark red, and that dark red is the same dark red that is dotting the surface of this moon. Alright, what's the name for MnS? First, let's make sure it's an ionic compound. So Mn is a metal because it's to the left of that staircase. S is a nonmetal because it's to the right. If you mix a metal and a nonmetal, you get an ionic compound. Alright, to name an ionic compound, take the name of the first element and write it exactly as it is on the periodic table. So Mn is manganese. For the second element, take just the first syllable. So S is sulfur. The first syllable is sulf, and so I'm going to write sulf down. Then add the ending ide, IDE. That shows that manganese and sulfur are in a compound. So far we have manganese sulfide. Because manganese is a transition metal, though, in that valley area on the periodic table, we have to say what charge is on the manganese in this specific compound, because it could change for different compounds. So, to figure out the charge on manganese, we're going to make a little algebraic equation. To find out the charge overall, what all the charges have to add up to, look in the top right. If nothing is written there, everything has to add up to 0. Now I have two elements. I have manganese and I have sulfur. Separate those by a plus sign. I only have one manganese because it doesn't have a subscript written in. So I write 1. I don't know the charge on manganese. That's what I'm trying to figure out. So in math, to say I don't know, you write x. I only have one sulfur. Doesn't have a subscript written in. And the charge on sulfur, because it's in group 6A, is -2. So I'm going to write in -2. So now I have x minus 2 equals 0. Add 2 to both sides. It cancels on the left. So x equals +2. That +2 is the charge on manganese. And so we're going to list it in the name as Roman numerals in parentheses after the word manganese. So MnS is called manganese 2 sulfide. That's the name for MnS. Manganese 2 sulfide. So if you react manganese with sulfur, you'll get manganese 2 sulfide. Now in nature, that's found as the mineral alabandite. And because it's being smushed together here, it's a slightly different color than what it is in a powdered form. How about COBr2? What's the name for that compound? So first, let's make sure it's an ionic compound. CO is to the left of the periodic table, so it's a metal. Br is to the right of that staircase on the periodic table, so it is a nonmetal. If you mix a metal with a nonmetal, you will get an ionic compound. So, to name ionic compounds, take the name of the first element exactly as it is on the periodic table. So CO is cobalt. Then, for the second element, take just the first syllable. So here, Br is bromine, the first syllable is brome. Then add the ending ide, IDE, to show that these two are in a compound. So far we have cobalt bromide. But because cobalt is a transition metal in that valley area on the periodic table, we have to say what charge it has in this specific compound. And to do that, we're going to make a little algebraic equation. Now, the charge of the whole thing is going to equal whatever is in the top right corner. If nothing is written there, the charge has to add up to 0. I have two elements, cobalt and bromine. I'm going to separate those by a plus sign. I only have one cobalt because no subscript is written in. I don't know the charge on cobalt, so I'm going to put X in parentheses. I have two bromines, and the charge on bromine, because it's in column 7A, is going to be -1. So I'll write -1 there. So I have X minus 2 equals 0. Add 2 to both sides, it cancels on the left, and you have X equals +2. That +2 is the charge on cobalt in this compound. And so we're going to list it in the name as a Roman numeral in parentheses after the cobalt. So COBr2 is called cobalt 2 bromide. So if you take cobalt and mix it with bromine, you will get cobalt 2 bromide. And that's often used as a catalyst in organic chemistry. How about HgI2? This can be different colors depending on the temperature. We'll talk about that in a second, but first, what's the name of this? So first, let's make sure that it's an ionic compound. Hg is to the left of that staircase, so it's a metal. I is to the right of the staircase, so it's a nonmetal. When you react a metal with a nonmetal, you'll get an ionic compound. To name ionic compounds, take the name of the first element and list it exactly as it is on the periodic table. So Hg is mercury, and I'm going to write it exactly as that is on the periodic table. For the second element, take just the first syllable. So I is iodine, the first syllable is iod. And then add the ending "ide" to show that these two are in a compound. So far we have mercury iodide. But because mercury is a transition metal in that valley area on the periodic table, we have to say what the charge is on mercury in this specific compound, because it's different in different compounds. Now, to find out the charge on mercury in this compound, we have to make a little algebraic equation. The overall charge is written in the top right. If nothing is written there, then everything has to equal 0. I have two elements in this compound. I have mercury and I have iodine. I'm going to separate those with a plus sign. I only have one mercury because no subscript is written to the bottom right of it. I don't know the charge on mercury, so I'm going to write X in. I have two iodines. Because iodine is in column 7A, it's going to have a -1 charge. So I'm going to write in -1 there. So I have X minus 2 equals 0. Add 2 to both sides, it cancels on the left. X equals +2. That +2 is the charge on mercury in this compound. And so we're going to write it in the name after the mercury as a Roman numeral in parentheses. So the name for HgI2 is mercury 2 iodide. So if you take mercury, which is the only metal that's liquid at room temperature, and you mix it with iodine, you will get mercury 2 iodide. Now, mercury 2 iodide is a different color at different temperatures. This is a common thing in lots of molecules. It's called thermochromism, when a molecule will change color with temperature. And it's the way that, say, mood rings work. There's just have molecules in them that change color depending on the temperature. For mercury 2 iodide, when it cools down, it's an orange, and as it gets hotter, it turns into this yellow. So the compound is staying the same. The way it's being smushed together is changing. And so how it's smushed together determines how it absorbs light. So it'll change colors. How about naming Fe2O3? What's the name of this? And this is rust. Rust has that red-brown color, and it is what makes Mars red. Mars is covered in rust. It's covered in Fe2O3. So what's the name for rust, for Fe2O3? Oh, yeah. When pipes rust, they can sometimes start dissolving into the water, and so you'll see, like on the news, that dark brown water that'll come out of some faucets is often caused by the rust that's dissolving in the water. So what's the name of Fe2O3? Well, first let's make sure it's an ionic compound. Iron, Fe, is to the left of that staircase, so it's a metal. O is to the right, so it's a nonmetal. If you react a metal with a nonmetal, you get an ionic compound. To name an ionic compound, take the name of the first element exactly as it is on the periodic table. So Fe is iron. For the second element, take just the first syllable. So for the first syllable of oxygen is ox. And then to show that they're in a compound, add the ending ide, IDE. So far we have iron oxide. Because iron is a transition metal, though, in that valley area on the periodic table, we have to say what charge is on the iron in this specific compound. And to do that, we're going to make a little algebraic equation. So the charges overall have to add up to whatever's in the top right of the molecule, and if nothing is written there, then everything has to add up to 0. Now I have two elements here. I have iron and I have oxygen, and I'm going to separate those by a plus sign. I have two irons, and I don't know the charge on iron in this specific compound, so I'm going to write X. I have 3 oxygens, and the charge on oxygen is -2 because oxygen is in column 6A on the periodic table. So I'll write in -2. So I have 2x minus 6 equals 0. Add 6 to both sides, it cancels on the left. We have 2x equals +6. Divide both sides by 2, cancels on the left, and you have x equals +3. That +3 is the charge on iron in this compound. And so we're going to list that as a Roman numeral in parentheses after the iron in the name. So Fe2O3 is called iron 3 oxide. So if you take iron and you react it with oxygen, and here you have liquid oxygen at a very cold temperature, you'll get iron 3 oxide, or rust. Actually, iron 3 oxide is sometimes used as a paint pigment, and rust is often associated with the disease tetanus, Tetanus is, with tetanus you have uncontrollable muscle spasms and contractions, as you see here. But it's not rust itself, it's not iron 3 oxide that causes tetanus, rather it's a microbe, Clostridium tetani, that lives in rust. Actually, rust, iron 3 oxide, is used in some medicines, including the over-the-counter drug calamine, which treats mild itchiness. It's only 0.5% rust, or 0.5% iron 3 oxide, but it's still in that medicine. Thanks so much for your attention.